Hello, everybody. Welcome back to Couch of Science. And today, here, my name is Michele Marini. I'm going to be the host for tonight. This will be, unfortunately, our last episode for the year, the season finale. But nevertheless, it's going to be a very nice, interesting conversation. We are going to talk about dinosaurs, which I know there is a very interesting topic for most of us, or at least for the kid part of our inside of us. But anyway, we are going to discuss about something very peculiar, but I don't want to tell you much more about it. As always, you can interact with us through the comment section. You can do on Facebook, on YouTube, depends where actually you are following us. And at the end of the presentation from our guests, there will be a Q&A session. So prepare yourself and don't be shy. You can definitely ask what you want. But before that, as always, we like to warm up the audience and start to introduce the topic through what we call Pill of Science. And today for the Pill of Science, I have with me here another member of the Couch of Science team, which is Renata. Hi, Renata.
Hello, Michele. How are you?
All good, and you?
Very good.
Yeah, are you a bit sad that it's the last episode, or you're happy about it?
I'm definitely sad. It's been very fun.
Yeah.
But we'll see what happens next year.
Yeah, exactly. We are definitely working on something more, something new. And of course, we want to go back in the bars to have the Pint of Science, the real event. For who's the first time that actually is watching us, this event was created when COVID basically forced us to stay at home. So part of the volunteering team of Pint of Science Belgium decided just to gather and to create this Couch of Science. We had a lot of different talk with a lot of awesome scientists, and you can find all of them in our Facebook page on our YouTube channel. But let's go on with the event of today. Let's not think about the fact that it's the last one. But why we are preparing this night, we arrived because me and you, we are part of the team that is promoting the events on Facebook, and we found memes because we love memes, and we found these particular memes, and from these memes start a quite intense conversation, I would say, inside the team. And at the end of this conversation, we realized that it was a very nice topic for appeal. So what is first of all, which is the meme? Because of course we want to share. Who follow us on Facebook probably already seen this picture, but I will leave you the stage to talk about that, and of course take your time.
Yes, thank you, Michele. And yes, this is the meme. So you've probably seen in the Pint of Science page as well, because we thought it was really funny. And you have probably seen memes like that, associating dinosaurs to the formation of petroleum, whatever. Even sometimes with this mind-blowing revelation that if petroleum is made of dinosaurs and plastic dinosaurs are made of refined petroleum, therefore, these toys are ultimately made of dinosaurs. It's like, wow. But as a lot of what we see on the internet, this sounds really cool. But is it really true? So I'll try to answer that question today. And to investigate this, we have to understand a bit on how petroleum is actually formed. First of all, petroleum, you probably know this already, but it's composed of carbon and hydrogen. Coincidentally, so is anything alive, including us. So the biomass, or the organic material in petroleum, of course, comes from something that was alive in the past. So far, so good. But This recipe is not starting from gigantic beasts, but actually from tiny aquatic creatures named plankton. They can be either animals, zooplankton, or plants, phytoplankton. So plankton is very, very abundant, and they're basically the base of the marine and freshwater food chains. And this is our main ingredient to form the petroleum. And to turn plankton into petroleum, we need at least thousands of years. Even millions of years are estimated sometimes. So it's not exactly a quick recipe. To start, the formation of petroleum is restricted to aquatic environments, such as oceans or seas, preferably in calm water conditions and in relatively warm temperatures to make sure plankton can thrive. And these conditions were especially the case during the Mesozoic, between 252 and 66 million years ago, when most of the petroleum reserves exploited today were formed. But all that lives dies, circle of life and all. And if a large amount of plankton dies and sinks to the seafloor, then the recipe is going perfectly. But there's a very critical step, which is these dead microorganisms, or this layer of dead microorganisms. It has to be buried very quickly to ensure not a lot of oxygen is available and to avoid that they get decomposed and disappear. So this rapid burial guarantees that all the carbon and hydrogen stay in place. And then there is the patient step. The organic layer has to then be covered by many, many, many kilometers of sediments. And this makes the pressure increase. And therefore, the temperature also increases in the layer there at the bottom. And while slowly heating up, this organic layer turns into a super concentrated of carbon and hydrogen that we call kerogen. Then when the sediment cover, the layers keep coming on top. And when the sediment cover applies pressure enough that the buried layer reaches temperatures between 100 and 150 degrees Celsius, this kerogen is finally transformed into two different phases. A gas component called natural gas that you've heard of before, and a liquid component called petroleum that for sure you heard of before. So going back to all of those memes, and this one shows how petroleum in black and the natural gas would be formed. So we saw that this must happen in an aquatic environment, but dinosaurs were living on the land. They were terrestrial animals. So no, petroleum and its downstream products, such as the plastic in the toys, it is not made of dinosaurs. So the next time you see a meme like this, you can spread the word saying it is untrue and why. But dinosaurs, they left behind some really cool stuff, which are fossils. So this word comes from the Latin fossilis, which means dug up. So this is how we discovered them. We dig up rock and find fossils. And from there, maybe comes part of the dinosaur petroleum confusion, since petroleum is called fossil fuel, one type of fossil fuel. But there's nothing to do with these fossils that we know well and that fascinate us since we were kids, as Michele was saying. So as you see, there are some examples. These can be body fossils that you see on the left side, such as skeletons, claws, that are ancient dinosaur parts. And also on the right side, you see some trace fossils, such as footprints, burrows, and even dinosaur poo that you can see with the black background. Even dinosaur poo can be preserved. And they are formed either by a full replacement of the bones or the parts left by the dinosaur by minerals over a long, long time, at least thousands of years, or as traces imprinted in sediment layers on the ground, which are then covered by more sediment and eventually evolve into sedimentary rocks that we see today. And in these rocks, we can dig up and find these treasures. And just as a final message, is that by studying the remains of life and the traces left behind, we can learn a lot about how dinosaurs, other animals, and also plants, how they lived and behaved millions and millions of years ago. And this is particularly important to understand better past environments in our planet. And of course, this helps us to understand and model our uncertain environmental future. So that's it from me. I'm sorry to disappoint you that your plastic dinosaurs are not made of actual dinosaurs. But I hope I could get you interested in fossils, which will be on the theme of today. And now I pass it back to Michele to introduce our guest. Thank you.
Thank you so much, Renata. Was really interesting. I will keep a bit more on screen this last piece, just because you can also find some extra reference from the QR code that you put here. Very nice idea. And yes, I'm a bit to say that I don't know. I'm a bit sad because it was nice the idea that I mean, not that nice because we are using dinosaurs, liquid dinosaurs to fuel our cars. But at the end was nice to think about that. But it's even better the fact that we have something to study that is much more interesting. And this probably will be one of the main topic of tonight. Let's see with our guest. So thank you so much, Renata.
Thank you.
And see you later. And I will just invite on the stage with me another member of Couch of Science. And he's going to be he's a member of Couch of Science and also Pint of Science. And he's going to help me to put in together some questions for our guest. Of course, as I said before, you can always ask questions to the guest at the very end during the Q&A. But we have on stage, please welcome on stage Matteo.
Hello.
Hi, Matteo. How are you?
I'm good. And you?
All fine.
Very excited for this talk.
Yeah. Actually, we are quite very curious about that, and also we are a bit sad because it's the last one of the year. But
mixed feeling.
Mixed feeling for this very, very mixed feeling year.
Yes.
And so, without waste more time, or actually to steal more time to our guest, I would like to invite on the stage our guest. She's a paleontologist. Right now, she's a volunteer researcher at the Royal Museum of Natural Science in Brussels. She's a very, very nice guest, and we are very happy to have her. Please welcome on stage Pascaline Lauters. And welcome, Pascaline.
Hello, good evening.
Hello.
How are you? How do you feel?
A little bit nervous.
Don't be.
Thank you very much for the invitation. I'm really excited about talking more about dinosaur with you and with the people who are attending tonight. So thank you very, very much for this opportunity. I think it's really nice what you're doing about all the organization of Pin of Science. So thank you very much.
Thank you actually to be here with us. And okay, I will not say much more. Today you are going to talk us about something very, very unique, I would say, because I never had the chance to know about that more. But we are going to discuss about the brain of dinosaurs, which is something that is not very, very common study, or at least is not something that normal people, I would say, they will think about it when they think about dinosaurs. So this will be very, very interesting. So I will not steal you more time. I will just leave you the stage. and tell me when you're ready with the slides, and I will just put on screen your presentation, and we just leave the stage, and the floor will be yours.
Okay, it's working for me.
Okay, perfect. So when you want. Good luck.
Okay, thank you. Thank you. Good evening, everybody. So indeed, I'm here tonight to talk to you about the brain of dinosaur. I spent several years working on that subject, and as you said, it's indeed not the first thing we think about when we hear about dinosaurs. It's not really about their brain, but there is a lot of things to say about it. First, a short introduction about, I guess a lot of you know what dinosaurs are, but I want to introduce a peculiar group of dinosaurs that I studied. So dinosaur appeared, I hope you see my mouse, I think you can see my mouse. Dinosaur appeared during the Triassic, and they were the first dinosaur and also the first mammals. They thrived during the Jurassic periods and the Cretaceous period, at the end of which most of them disappeared. I say most of them because actually dinosaurs gave birth to the birds, and birds are dinosaurs, and as you know, they are still with us today. And so actually they didn't completely disappear. Birds are dinosaurs and still with us to this day, but all the other groups and what we picture as the dinosaurs all disappeared at the end of the Cretaceous. You have several groups of dinosaurs. The first big group is the Saurischia, where you have the theropods, who are very famous. They're mostly meat eaters: Tyrannosaur, Velociraptor, Allosaurus, big names. You have also the sauropods, who are famous for being usually really big. Long neck, long tail, herbivorous dinosaurs. And you have the ornithischian, who are very diverse, with stegosaur and ankylosaurs, triceratops, and thick dome-headed dinosaur, the pachycephalosaurs, and the ornithopod dinosaurs. Ornithopod dinosaurs are mostly known, the most famous names are Iguanodon and hadrosaurs, also known as the duck-billed dinosaurs, and I've been studying this group of dinosaurs. First, the question you may ask yourself is, how can you study the brain of an extinct animal? Because indeed, the brain is a really fragile organ, and when the animal dies, it will disappear really quickly, it will decompose, and it will be gone really fast. So in some really exceptional circumstances, there can be a mineralization of the soft tissue of the brain. That's what you can guess on the right part of this slide. Something that was described a few years ago from an animal that should be closely related to Iguanodon. And upon study, it seemed that some part of the brain had mineralized. We can also study a natural internal cast. So that means the internal part of the fossil will be filled by sediment. And it can happen that later the fossil itself is destroyed or disappear. What you see on the left is the inside of a seashell, actually. So the seashell got completely filled by sediments, who hardened. The seashell itself disappeared, but the cast of the internal cavity of the seashell is still exists, is stayed upon this time, and that's what we found back. This is an internal cast. When we talk about the skull, the internal part of the skull is named endocranial cavity, and to be short, we call that an endocast. It's much more easy to use, and that can happen, of course, with skulls too. But of course, it's not easy to find. It's rather rare, and that make it difficult then to have a lot of data about the brain of extinct animal, because we hadn't so much specimens to study. So another solution to have more data about it is to make the cast ourselves. Oh, I have a problem with one of the pictures, but whatever. The first material was used is plaster. So they filled the skull of the fossil, of the skull of the animal with a plaster. To retrieve the cast, because plaster is of course hard, they had actually to cut it open, which is of course a tiny bit a problem. I mean, you have to destroy or at least cut and damage the fossil to retrieve your cast. Sometimes we don't have a choice to access to some data or to pick samples. You have to provoke damage to the fossil, but it's better to avoid it if it's possible. You wouldn't want to destroy a unique specimen, for example, or really important specimen. So what we can now use, and which is much more useful than plaster, is artificial material like latex, rubber, and silicone. I myself use silicone the most. This is really useful. It's a polymer. It's really elastic, really supple. So you can pour some inside the skull. It will cover all the inside when you manipulate it, and it will take a lot of details. And later, when it dries, because it's elastic, and when you remove it really carefully, you can pull it out of the skull without doing any damage to it, without having to cut it open or whatever. And you will have the representation of the inside of the skull. It can give you a lot of details about it. It's elastic, it's stable, so it's really useful and very nice to use. As you can see, I will not talk about the cranial nerve so much. You will get a lot of details, and on the right side you see the undercast of crocodiles on the top, and the one on the bottom was not showing properly. It's the one of extant bird, and it will so give you a lot of information. You can say a lot of things on these undercasts. Another techniques you can use is CT scan, so computed tomography. This is just the technology. This is the technology of the X-rays. So when you have an accident, for example, or you fall and you hurt and you go to hospital because maybe you think you broke your leg, they will most of the time take a radiography of your leg. They're sending X-rays towards the specimen, the patient they want to study, and the X-rays will go through the tissue, and they will be stopped by hard tissue, really dense tissue. They will appear white on the picture, and soft tissue will not stop X-ray, will go through, and this will appear gray or darker. So the same techniques is used for CT scan, except that it's the source will be moving around the object of the patient. This is used very often in medical imagery, but we can also use it on fossil specimen. And you see the result on the right. This is, you get actually three-dimensional cartography of the density of your object that you can then, through specialized software, analyze and cut and see and go through as you want, select some parts, remove other ones. And that's what I did also for my PhD. I went to hospital to scan some skulls, and then through a specialized software, I selected the endocranial cavity. You need to do it slice by slice, so it's really time-consuming. It's a lot of work. But when you're finished, you can ask the computer to reconstruct all the parts you have selected, and that will give you also a lot of data about the endocranial cavity. And we will see better examples later. I hope this works. This is an example of something that was reconstructed. The skull of an iguanodon that went to the CT scan. I didn't make the animation myself. It's a colleague who did it, but you have the skull and I could extract the brain, and this is how it will appear. You can make really nice reconstruction with it. Yeah. Okay. Now, I want also to talk about the idea that you probably heard, and it's very common to hear, that dinosaur had a really small brain. This is something that is really often said, and one of the famous facts you can find in books, for example, at least I found in some books, it's that some dinosaurs, like the Stegosaurus, you see a picture on the slide, who was a rather big dinosaurs. An adult will weigh 4 tons and a half. It was living in Jurassic, and as you can see, his head was rather small compared to its body, and it was often said that his brain was the size of a walnut. And then you had this kind of jumping to the conclusion he had a really, really small brain for his body size and must have been really stupid. This is some idea who pervaded and was repeated in the literature. It didn't help the fact that when we look at the brain of extant animals, when you look at mammals and birds, the brain fill up nearly the entire cavity, if not most of the cavity. So if you have the volume of the endocranial cavity, you have the volume of the brain itself, the organ. And sometimes you have nice details, and about the different parts of the brains, you get a lot of information. But if you look at crocodiles, the picture is really different. In crocodiles, the brain itself usually doesn't fill the endocranial cavity. It is surrounded by some tissue, connective tissue, sinuses, and it was often said that the brain itself will only fill 50% of the endocranial cavity. And people then applied the same conclusion to dinosaurs, saying that the endocranial cavity of the dinosaur, the brain wouldn't fill it completely, but only 50%. So you have already a big dinosaur with a small head, and just a rather smallish brain, and even that space will be still shrink to 50% to say it had a really small brain. I will come back on this later, but yeah, it's to say that it's something that we can still find in some books, so that you will hear on maybe in some documentaries. I wanted to show you this picture. This is the pink dinosaur is actually talking to the visitor, and he's saying, "Hey, I may be a giant, but my brain has the size of a pea." And then he proceeds by insulting you. I'm not going to translate that part. This is a picture I took in Open Air Museum some years ago. So it was supposed to be somewhat educational, and still they're bringing up this idea that they had extremely small brain, and voila, something. There are so many things that are wrong with these pictures. It's terrible. No, I want to talk about this. I'm introducing this because there is something that's I saw on the skull I studied was really interesting. What you see on this picture that I highlighted with arrows are what we call valleculae. That's the scientific name. And they're actually the trace of the blood vessels. So these lines are the imprints of the blood vessels that were covering the brain. And that means when we see that kind of trace, that the brain was in close contact with the bone wall. So it's really exciting, in fact, because that means, yeah, the brain, at least for that part of the endocrine cavity, came really close to the bone walls and allowed the prints of the blood vessels to be preserved. And that's something I observed that can be observed in some dinosaurs and something I could see on some of my specimens. So it was not anymore only 50% of the cavity is filled by the brain, but there will still be a bigger proportion of the brain that will fill up the cavity. And you see here another picture. This is on the endocast. And once again, you see the fine lines. There are proof that there were blood vessels and it was in really close contact. There was a really close contact between the brain, surface of the brain and the bone wall of the skull. I'm going now to show you a few examples of the brain of dinosaurs. I will start with Iguanodon and Mantellisaurus, who are actually closely related. These were dinosaurs. You must go see the Iguanodon in the Museum of Natural Science. We have a really beautiful collection, and they are really iconic dinosaurs for Belgium. Mantellisaurus was also found close to the Iguanodon of Bernissart, and it's a more gracile specimen. It's actually another genre, another genera, but it was closely related. So on the left you have Iguanodon, and this is reconstruction were made by with CT scan. We can see a few things on these scans. First, the olfactory tracts were there on the right part of the image, were rather large, and that would have mean that they had so rather big olfactive bulbs and most probably a really good sense of smell. That's something we can infer from this kind of feature. You also have the cerebral hemisphere, the anterior part of the brain was enlarged. And something that's interesting is also that the brain itself, the shape is rather straight. It's a tiny bit oblique, but you have you can trace a straight line between the two. On the right side, you have an example for Mantellisaurus. So as you can guess, there is a part was missing. It's not that the brain was split in two, it's that I couldn't reconstruct this part of the brain because of preservation of the skull. And I still could show the cerebral hemisphere and olfactory tract, were rather important. And something that is interesting and that we can guess on this picture is that it was not as straight as the Iguanodon. You actually have a kind of S shape was forming if you want to try to connect the two parts of the brain. There is an angle that is what we call a flexure, that at 2 points here and there, the shape of the brain will bend. There will be an angle. And I will come back to that at the end of my presentation. But this is interesting to notice in some of the endocast. You see it much better, this flexure, you can see it very good on some theropod dinosaurs where you have a clear angle between the various parts of the brain. Then there is Lordosaurus, who was also a kind of iguanodon, who was really massive, coming from North Africa. And we can already see there are very different things going on for this dinosaur. And the interior part of the brain was much smaller and oval, not so laterally expanded than for iguanodon. The olfactory tract were here are rather thin, really small. So contrary to his cousin iguanodon, he wouldn't have such a developed sense of smell. And at the bottom, I want to talk to you about the pituitary fossa, also where the pituitary gland is coming, also called hypophysis. This is interesting because this is a gland that's producing various hormones, and the most famous is the growth hormone. And in this case, the pituitary fossa is very small, which is strange because it was a really big dinosaur, really massive. And actually, I cannot explain this at all. Why there was a problem with preservation or something aberrant, but for a big animal, this is well known that for a big animal, it would have big hypophyseal fossa, and it will be bigger. But this is not what we observe by Lordosaurus. And on this picture, you see better the shape of the anterior part of the brain. This is a dinosaur that's really not famous, but Tyrannosaurus is actually between the iguanodon and the duck-billed dinosaur. It's really in between. It's one where you can see some of the valliculae. It was the first time that we found traces of valliculae of such a primitive dinosaur on this lineage, so it was really exciting. That means we have when we see the shape of that part of the brain, we can really say that in the living animal, it had the same shape. There was not so much connective tissue. This is not the same for example, that part of the brain, you will see this peak. It will probably be a lot more of connective tissue. It will not reflect the shape of the brain itself in the living animal. Something I could do also on this cast is I had the chance to get a cast of the inner hair of the animal. This can be rather useful. You can infer something about the senses of the animal, and sometimes I didn't do it for this, but some people will be able to give a range of hearing of dinosaurs. So, for example, Triceratops, Ceratopsian, will have heard very low range, low frequency sounds. For Batyrosaurus, the shape of the horizontal semicircular canal, its size, excuse me, will have it will give us something to know something about what he was able to do. Like it would have probably been a rather agile animal, probably bipeds. At the moment, we cannot prove it or not if it was the case, because we don't know much about it. We only have part of the skull, some bones of the arms, so we cannot have a full reconstruction. It will be really nice to find more bones and to see if this validates or not this hypothesis about the animal being agile biped. And then I will talk to you about Amorosaurus, who's a real duck-billed dinosaur who was living at the end of the Cretaceous. And yeah, this is I'm sorry. He was living at the end of the Cretaceous in Russia, and you see, as we saw for Iguanodon, the brain is really straight. There is no bend, no flexure in it. You have really large cerebral hemispheres, big olfactory tracts. About the cerebral hemisphere, it's also one of the dinosaurs where we found traces of the valleculae. So we're pretty sure that part of the brain, of that part of the cast, represent the brain how it would have been in the living animals. And on this one, you can also notice a pituitary fossa, who is really different than the one from Lodosaurus, has a really different shape, and it's more bigger than the one we could observe in Lodosaurus. So Lodosaurus is really strange on that, about that. So I will try to resume everything I said until now about what difference we can see. So it is just one lineage of dinosaur, and we already see difference between them. Some of them had not so good sense of smell. They had small olfactory tracts. I will not rely so much on their sense of smell, but a lot of them actually had very large olfactory tracts, most probably olfactory bulbs. They're often difficult to reconstruct, but the tracts are already giving us some clues about it, and most of them would have a good sense of smell. This is about the flexure. I told you I will come back to the shape, the general shape of the brain. And this is interesting because it's something we notice is that most of the small dinosaurs will have really prominent flexure. There will be a bending of the brain. And in larger animals, the brain tend to, I will say, unfold, the angles soften, and you have a more straight shape of the brain. And it seems really related to the size of the animal. It's like small animals don't have much space, and so the brain got compressed. It's particularly obvious in birds, for example. Birds, if a small... there is not so much room for the brain in the skull of birds, especially they have really big eyes. Most of the eyeball is hidden by skin. They have really big eyeballs, and it kind of push the brain. They don't have room for it, and so it will be packed. And it was not as bad for these dinosaurs, but you see it also when you look between individuals of different ages. The babies, the very young one, they have a small skull, and they have brain where the S shape is much more prominent than by older animals. This is not an adult, but it's nearly an adult, and the endocrine cavity had more space to expand. There was more room for it. And so when we think about the Iguanodon, the big Iguanodon had a more straight brain, and the smaller one, the Mantelizurus, was actually smaller, gracile. It shows the shape, so it will seem there is effectively a correlation between the two. And then I will speak about especially the cerebral hemisphere was, I would say, the most interesting part of the brain, and that we can... there is a lot of things to say about this. I will come to this. This is the eat your vegetables part, not really. I told you there is a lot of question about the size of the brain. Had they or big brain or not a big brain, and very often we hear that dinosaurs had, for their size, really small brains. They're actually a way to calculate it. That's what we call the encephalization quotient. The most important is you will take the weight of the brain and the weight of the full body of the animal. You plot it in the equation, and it will give you some numbers. So when an animal has a brain who has just the right expected size, it will be 1. And if you have a value below 1, that means that the animal has a brain that is smaller than what you would expect for an animal of that size. And if it's below 1, that means then that the brain is bigger than what you would expect for an animal of this size. And I'll set here, so this is an equation especially made for reptiles. I set there on the side different values, and as you can see, there can be a lot of variation. That can be explained by the fact that sometimes it's not easy to determine what the weight of the brain and what the weight of the body was. The weight of the brain, because people will use different proxies to determine the weight of the brain. Was it filling 37 or 50 or 60 or % or more of the brain cavity? I often went with a 60% because it made sense for ornithopods. The anterior part of the brain was filling the skull, but the posterior part of the brain, we don't see much details. There was most probably a lot of connective tissues, and that part is not representative for the brain, so we'll use a value of 60%. But you will have different values for different group of dinosaurs. Also, to determine the body weight is sometimes really difficult when you don't have a full skeleton, and the way you reconstruct it, and that may explain some of the very sometimes different values you will find. But you can still see some trends. These are theropod dinosaurs. They seem to have rather high value for their body, especially Troodon, who has a really, really high number. The sauropod dinosaurs are very small values, kind of made sense. This dinosaur, we have a very big body, really gigantic body, and rather a small head. And we find here the ornithopods. So as you can see, they're above the value of 1. So that means their brain is actually bigger than what you would expect for this kind of animals, a tiny bit bigger. And I find it was quite interesting because actually anterior part of the brain is associated with really complex behavior. And we know from other body of evidence that ornithopods were most probably living in big groups. We found bone beds, that means places where we find a lot of bones of usually the same species together. And that means they died together, or they were living in big groups, and you wouldn't have that kind of accumulation for more solitary species. We found, this is really famous, it is a representation of nesting ground for Maiazora. These dinosaurs were making nests together, so they all laid eggs more or less at the same time, and they were doing it together at the same spot at the same time. That means, once again, prove they were living in communities, even maybe raising their youngs, so showing some kind of parental care. So we have more and more clues, and it's more modern image, that dinosaurs were actually really active animals. They would grow very fast. They will be lead very active lives. They will even more certainly have a large range of behavior, sexual parade, and so on. And I think it's really not deserving to call them stupid and small brain, because they lived for a really long time, lived on the whole planets, and had a lot of amazing feature, and it doesn't add up with grey, stupid animals. This is the end, I guess. Thank you very much to your attention. A special thanks. I couldn't put the name of everybody. Met all my colleagues and the people at this institution who helped me during my PhD. So I'm going to... I can stop this.
Thank you so much, Pascaline. Was very interesting, and it was really cool. This stamp, I don't know how to call it, of the brain that you were able to do through the skull, and I was actually amazed on how much information you can gather just through that, just from the shape of the skull and the shape then of the brain. It's unbelievable. And I already seen that there are some questions. So I don't know, Matteo, do you have a questions? In the meantime, from the audience, if you have questions, just drop in the comment section. We will have 10-15 minutes Q&A moment, and Pascaline will reply to all your curiosity.
I think we can kick off, so we give time to people to gather all the questions. Amazing. It was really a wonderful presentation. It gave me really feelings of Jurassic Park. I think there was even one in which Dr. Grant actually had one little thing in which he was able to make the same sound of a velociraptor. It was the same thing. It was amazing. I don't think it's scientific, but okay.
Yeah.
Just one question, especially about the last part of this encephalization quotient that you talk about, and in general of this. All the shapes of this brain, they look so different from each other. How would you put them in an evolutionary scale? I mean, it was just going all direction, or they were going towards something?
About ornithopod dinosaur, or more generally?
I would say in general.
Well, for some groups, we're gathering a lot of data, and I have a lot of colleagues who are, in the last 10-15 years, a lot of people became interested because we now have access, especially to the CT scan more and more. We can gather more data about it, and something it was really difficult to do in the past. And so we can have more evidence, but still it's at the moment really patchy, and it's difficult to show some trends in some groups. So to answer your question, for ornithopod dinosaur that I know very well, I will say there was a clear increase in the anterior part of the brain. That was something that I would really expect comparing other ornithopods. There was the anterior part of the brain really became bigger and more prominent compared to older represented. I see the sense of the smell. Seems they all had a good sense of smell. I know somebody who worked on theropod dinosaurs. Also, he studied a lot of cast, and he discovered something really interesting. It's that first, the brain of some theropod dinosaur really look like the bird of brain. It's pretty amazing, actually. When you see the endocast, it's really difficult to distinguish from the cast from the brain of a bird. So, but they were still dinosaurs, and he inferred some things about their behavior and made the hypothesis that the shape of the brain, and they were really agile dinosaurs. There are some. I couldn't show it on these ones, but you have sometimes floccular lobes on the side of the brain. You can see it in birds, you can see it in some dinosaurs, and that is show animals who are really agile will have good eye-hand coordination. Will make sense because they were most probably hunting small and really fast prey, so they had to be able to grab them really quickly. That's something that can be said for them. For other group, it's really difficult at the moment because we don't have enough data to see trends in what's happening or not.
Okay, thank you.
So in general, this is a quite new field for the study of dinosaurs.
This is quite recent. In the past, it has been done on mammals. It's something I think I forgot to say in my talk. You had some paleoneurologists like Tilly Henninger. She's not famous by herself, but she's actually the founder of modern paleoneurology, and she studied a lot of mammals, especially. But on dinosaurs is quite recent. There are a lot of things coming out. I saw several new papers in the last few months. But in some groups it's getting really well known, and in other groups it's at the moment still probably under study. We need to wait a bit more, get more data.
Okay. No, it's very interesting, and in fact, we have several questions here from the audience. I will start with this one. So we are talking about the brain, and of course, part of the function of the brain is to have to collect memories. So Anna is asking, what has science learned so far in relation to dinosaur memory? How similar or different will it be to bird or even human memory? So it's something that it's we are very far to understand these, or we have some ideas, some theories.
I think it's a really interesting question, and I'm afraid it's really difficult to say at the moment. As I hinted at the last part of my talk, so the anterior part of the brain, the telencephalon, the cerebral hemispheres, if you picture the human brain, which is a picture everybody usually has in his mind when we talk about the brain, that's what you see. In humans, this is the most part of it. It's really highly developed, and this is interesting because it has a lot of what we would say high functions like memory, intelligence, relationships, but to know more about which part is developed or not, in other animals, I'm really curious when I see studies about the abilities of extant animals, and I think it's not easy to determine their level of smartness or not. So to say that about dinosaurs, it's even more difficult. That's why I think it's so interesting that we see a development of the anterior part of the brain, and we know that these dinosaurs were actually living in group, probably having complex relationship, most probably sexual parade, and maybe behavior of parental care. But to know more about memory specifically, I don't know how we will infer that. That would be really nice to know, but at the moment, I couldn't do a comparison or put a scale on what a dinosaur would or will not be able to memorize.
Okay. So it's of course not that easy. We can just make theories, but it's still very, very interesting. And keeping going on the function of the brains, Helen is asking, how do you guess on the different functions of dinosaur brains? Are the same functions found in brains across all species?
Yes, actually, there is some kind of conservative way of dividing the brain. The shape will be different, but the organization itself of the brain will be similar. So if we can distinguish the different parts of the brains, the anterior, the middle part, the cerebellum, then we can see if there are, and that's what you can do on extinct animals, see if some parts over time will become bigger or will be bigger than some other parts. Like the interior parts or the cerebellum. Cerebellum is more involved into agility and that kind of thing. So if you can define the parts, you will have an idea of if it's getting more important, if that species compared to other one or not.
Okay, very interesting, and still we have a lot of questions, but unfortunately we don't have so much time. So what actually you focus a lot of your discussion about the shape of the brain, and there is a good question from Bram. Thank you for your interesting presentation. Do you have any idea how the shape of the brain straight curve can influence its functions?
I know that girl. Good question. I'm not sure it will not really influence the function of the brain. It's more that the shape is constrained by the available space. So in big animals, it's somewhat they have more room to expand. The brain cavity has more room, and the brain has more room to expand, and will tend to be straighter. In some other animals where the skull is smaller, the brain cavity is smaller, and you see it very well in birds. I had to prepare some bird skulls in the beginning of my PhD. Remove the skin and so forth, and the soft tissues. And it's pretty impressive, or actually the skull, the brain is pushed back at the end of the skull. The eyes, the orbits of birds are extremely big and give really the feeling that the eyes are pushing the brain and it needs to be compacted. And so you will have this curved shape more apparent. And that's something we see in dinosaurs too, where smaller dinosaurs have more often a shaped curved S-shaped or Z-shaped curve, and the bigger one tend to have straighter brain. So it will more be related to the size of the animal, not so much the function.
Okay. So it's basically the shape is much more related on the space available, basically. So it's not so much related on the function.
No.
Okay. But actually now. Oh, go on, Matteo.
Maybe related to that. So you said that the birds tend to have similar brains, no? And no, please go on. In terms of the shape.
Finish. I'm sorry.
If this is true. So if the birds, they have similar brain, I'm wondering is this connected to the fact that they fly? Because the dinosaur didn't fly, I'm assuming. Not all of them, at least.
Well, that's something that's really interesting, and I think several people are working on this at the moment. I'm not sure about the last conclusion, but it's really a hot topic to know exactly what's happening, because the only living dinosaurs are birds, so they represent a kind of really, I would say, evolved, derived state of this group. But they're, of course, also highly specialized. And to see, that's something at the moment I cannot answer. I know there are some research going on, but I'm not sure about the conclusion of what is the influence of flight or the size of the brain. Let me think. I think I read something not long ago about it. It was published this year but it was especially about birds and the size of the brain in different birds, especially about cetacid and corvids, because they are the birds who actually have a rather big brain, and they're also the one who are showing the most cognitive abilities. Psittacids is the parrots and the parakeets. We know they're really famous for being able to solve problem, have a good memory, and what did I wanted to say? They're usually considered smart, and corvids are actually really, really smart too. They can do a lot of things, a lot of analyze, and it's really interesting for that. And they developed really high brain for really big brain for their size. But how it went from dinosaur to birds at the moment, I will need to look it up to answer more precisely. So maybe it's something I can get back to the person when I have more info about it.
Yes, sure.
Sure. Actually, at the end of this talk, we are going to share your email. So if somebody, here we go. Thank you from the guys in the backstage. So if you have any other question, guys, you can just send an email to Pascaline. She will be more than happy to reply, I guess. And I have actually a very last question, which is a silly question. But unfortunately, I never had the chance to speak with a paleontologist, and I really would like to ask this. But so over the last years, we have seen actually since the beginning of cinema, we have seen, and also fantasy literature, we have seen the description of dinosaurs and dinosaurs in movies, Jurassic Park, The Lost World. There are many movies. In your opinion, as a paleontologist, as a scientist, for you, what is the worst, the biggest error, or the biggest fake news associated with all this kind of stuff? You know, what is something that you see it and you say, "Oh my God, this is so unfair and so untrue"?
Oof, my
Well,
trick question.
Because I grew up with the idea that dinosaurs are reptiles came from dinosaurs, but actually they were more close to birds than reptiles in a certain way.
Yeah, they were in between crocodiles and birds, if you want to take extant animals, but they were indeed close to birds, and actually some of them. You will have a time travel machine and go back to the Cretaceous, and you will see some dinosaurs, and you will actually think they are birds because they were covered with feathers. They were small. They would look like birds, but they were still dinosaurs. To answer your question, wow, there is. I will think I also saw the Jurassic Park movie when I was younger.
Yeah,
yeah, of course. I think there are about that movie, especially the first one. There are two things. There are stuff who are not true in the movie, but you need to see it as a movie.
yeah, of course.
Yeah, I say that because a lot of people, it's really impressive, of course, and I'm also. I'm a visual person. I remember visual clues, and I'm really impressed by image, and so I will tend to remember that. But a lot of people see the movies and they forget to question which is true and which is just fantasy, because it's a kind of science fiction, and they remember science, they forgot fiction.
Yeah, indeed.
Because there are things that are actually really good in the movie. You have to say Steven Spielberg picture dinosaur in a kind of really modern way. They were fast, they were running all the time. They look like warm-blooded animals. They're really active. They even really smart. They can open doors, which is too much actually. But he created other parts for the wow effect to give more things, and people tend to. Of course, it's a movie, so you don't have a warning to tell you this is fake or we don't know, and people think everything they see it's kind of true. So they sometimes come to museum with these ideas and they're like, oh, it was like that. Yeah, that's a real one. Sorry, it's not like in a movie. We actually did really good in picturing them as living animals. Something I will reproach because I'm a biologist, and I find it's not only about Jurassic Park. In some movies, the carnivorous animals, the meat eaters, are often depicted as bloodthirsty, crazy killing machines.
The villains of the story.
Yeah, and that's kind of in Jurassic Park. It's kind of a bit too much. Of course, it's a thriller also. You want to be scared by these dinosaurs. It's working really good, I think.
No, indeed. I still, when I was a kid, I was really impressed by the scene in the kitchen with the Velociraptor. Was really. Oh my God, I was so scared about that.
It was scary because, but they depicted as for that part. They depict as a monster, but you have the same with movies about sharks, of snakes, of giant crocodiles. It's it's not an animal anymore. It's a machine to kill the hero of the story. You will never do it, but you're really scared for him. Because we are talking about also Jurassic World, who's kind of revive of the franchise.
Yeah,
if we really have to.
If we have to, I can expand. I will maybe not, but I really disliked it.
Exactly.
There are many reasons why I actually really dislike it. And actually, here we have this fantastic
really good
comment from Alice that she's 11. And she's just saying, I think that the biggest error is that they all roar.
This is a really, really nice remark indeed. Also.
Okay, Pascaline, thank you so much. It was a very, very interesting conversation. Unfortunately, we cannot reply to all the questions, but definitely if somebody in the audience wants just to reach Pascaline, we just put, here we go, the email. You can just send an email to her and she will reply to all your question.
Yeah, I will say I will do my best to reply. Please, sometimes I cannot check that email address every day, but I will do my best to reply to everybody if you have questions.
And for everybody, so guys, this was the season finale for this first, I would call, season of Couch of Science. It was a weird, crazy year. And was really, really strange for everybody. I will ask to all the rest of the team to join us on screen if you want, guys. Unfortunately, Anna and also Marion and other people that join us during this journey during this year are not here, but we also send a hello to them and a huge hug. And thank you so much, guys, to be with us. Thank you to all the team to collaborate and to work on backstage. Thank you all the speakers. Pascaline is just the last one of a long list of people that join us in this small rectangle of your screen. And I hope that in a certain way we were able also to release a bit of stress that you gathered all together from the COVID situation. We hope that next year everything is going to be fixed. We don't know if we are coming, and we don't know in which form we are coming back. But I think that we will be again on air. I just say on air. We don't know exactly what it is going to mean, but we are going to be there. And for me, it was a pleasure to be the host for all these events. And it was really nice, and even if my English is completely Italian, but still, I hope that everything was clear, more or less clear for everybody, and it was not too bad. And I think that at this point we need just to close all of this. We had our beers, so we have our couch, and of course you can contact us if you want on our Facebook, on Instagram, Twitter. By email, there is the email just written below here. And if you want to join the Couch of Science family, but also the Pint of Science family, let us know, because there is a lot to do, and there is always a place and a beer for everybody. And I don't know, that's it. So you can see all the previous episodes on Facebook and YouTube. please let us know and give us as much feedback as you can, because the more the feedback, the better will be the future events. And thank you also to Guillaume and to Céline, which are the responsible for Pint of Science Belgium, to all the Pint of Science Belgium family, but also the Pint of Science World family. And have a nice end of the year. Have a nice Christmas. Have a nice New Eve. And I don't know, guys, if you want to say something else, because I have the impression that I'm talking since forever, so I will just shut up. Otherwise, thank you so much.
I just want to give a final thank you to Pascaline, because it was a very nice way to wrap up our season this year.
Yeah.
We all love dinosaurs.
We were so happy to have also a talk on dinosaurs, because it was the cherry on top of this cake that was Couch of Science in this crazy year.
Thank you very much.
And thank you so much to all of you guys in the audience. See you soon, and stay safe, and good night.